Alright, so let's talk about these so-called weird cases again. And what I mean by weird cases, well, there are two possibilities for weird cases. One is that there are no solutions, and I was calling this inconsistent because the two equations don't make sense together. They're not consistent with each other. And the other is infinitely many solutions, which I might write as uh, infinitely many solutions sometimes, and this is called consistent because here, yes, there are solutions, so the two equations are consistent, but they are dependent upon each other because, once I know everything that's on one of the lines, then I know everything that is on both of the lines. So let's do an example first where there are no solutions. So select my paintbrush and let's try to solve in any case, say x plus 2y is equal to 3, and let's say negative 2x minus 4y is equal to 5. Okay, let's try substitution because we can easily solve for x in the first equation. So let's take x plus 2y equal to 3 and solve for x. I subtract 2y from both sides, and I end up with the equation x is equal to negative 2y plus 3. Now I plug this into the second equation. Negative 2x minus 4y is equal to 5. Well, x is equal to negative 2y plus 3, so what I get is negative 2 times negative y plus 3 minus 4y is equal to 5. I distribute. Negative 2 times negative 2 is positive 4, so positive 4y. Negative 2 times 3 is negative 6. Minus 4y is equal to 5. We collect like terms. 4y minus 4y gives me 0, so I'm left with negative 6 is equal to 5. No, that's not true. That's not true. Negative 6 is not equal to 5. And this is a joke that I'm only going to make, I'm not even going to make this joke. There's a bad joke I make about two numbers that are not equal to each other being equal to each other. In any case, let's continue. So what this really means is that both equations cannot be true for any values for x and y. Any values that make the first equation true will make the second equation false, and vice versa. Okay. And the reason is because we got down to this false equality right here. So let me sort of describe what is going on in general then. So, 1. There are no solutions if the method of solving you use leads to a false equality. And when it comes to substitution, you'll often just have like some number is equal to some other number that are not equal, so that's false. When you use elimination by addition, generally you'll end up with something that looks like 0 is equal to some number, which again is false, but generally you'll have 0 equals some number. With substitution, you might have just two different numbers, but in elimination, it's going to be 0 is equal to something non-zero. In any of these cases, this implies no solutions, as I say right up here. Okay, now let's try an example where there are infinitely many solutions. Excuse me, let's try to solve. Let's do, almost the same thing. X plus 2y is equal to 3, but this time let's do negative 2x minus 4y is equal to 6, negative 6, and let's use elimination here. Now what is going to be easy to eliminate? If I multiply the top equation by 2, then I'll have 2x minus 2x, that'll cancel. So let's multiply top by 2, and what we end up with is 2x plus 4y is equal to 6, and negative 2x minus 4y is equal to negative 6. And well, that looks a little bit funny because if we add these together, 2x minus 2x gives me 0, 4y minus 4y gives me 0, so my left-hand side is 0, and 6 minus 6 is also 0, so I get this. Well, this is true. This actually implies that there are infinitely many solutions. Okay, so let's go back and write something down about this. Oops, sorry. So 2, there are infinitely many solutions if the method of solving you use leads to a true, the top should have said a false equality, so apologies about that. But if the method of solution you use leads to a true equality of numbers. So when you do substitution, you might end up with something like 3 is equal to 3. It might be 0 equal to 0, but it could be 3 is 3. I don't know. It could be any number equal to any number. When you do any elimination, it will always end up with 0 is equal to 0. In either case, these lead to true statements, and this implies infinitely many solutions. Now, how can we actually sit down and write these infinitely many solutions? Well, what we do is we introduce something called a parameter. So we introduce a parameter k, and k can be any real number. So that's really what a parameter is. Then we set x equal to k, which says that x can be any real number. And we write y in terms of k. Okay, so how do we accomplish that? Well, we use our original equations over here to do that. You can use either one of our original equations, it doesn't matter. What we're going to do is we're going to solve one of these equations for y and then replace x with the value k. So what we're going to do is solve one of these for y. And so let's take the first one, so the first one says x plus 2y is equal to 3. I subtract x from both sides, and I get that 2y is equal to negative x plus 3. And then I'll divide both sides by 2. That really means both of the terms on the right-hand side have to be divided by 2. And that leaves me with y is equal to negative x over 2 plus 3 over 2. But since x is equal to k, we have that y is equal to negative k over 2 plus 3 over 2. This tells us that our general solutions are given by k, comma, negative k over 2 plus 3 halves, and here k is any real number. So this is our general solution